Okay, so let's see a very simple example of how can I calculate the distance of a vector, for example this one, from a subspace. For example, let's take this subspace. Okay, it's in R3. You can see that this vector is on R3 and is not going to be 2, but let's see how I'm going to calculate the distance of a vector from a subspace. The answer is that I'm going to calculate the distance of the vector from its orthogonal projection to the subspace. So I need to find the orthogonal projection to this subspace and then take this vector, reduce it from the orthogonal projection, and take the norm of this difference, of this subtraction. You can see if this is V, for example, and this is the subspace, I need to calculate the distance between them. So this is here, the distance. So I need to take the orthogonal projection of the vector to the subspace and then calculate the distance between them. So this is what I'm going to do. So how can I do that? In order to do that, I needed the subspace will be to find an orthogonal basis for the subspace, or even better, orthonormal basis, but at least orthogonal. So let's start by checking if this span is based on an orthogonal vectors. So I just take the two vectors and make a dot product between them. I see that I'm not getting 0, so they are not orthogonal. So in order to convert them to an orthogonal basis, I need to use the Gram-Schmidt process. Firstly, I need even to check that they are linear independent, so they will be at least linear independent, so I can say that they are bases. They will. And now, in order to convert them to orthogonal basis, I need to use the Gram-Schmidt process. In this process, you can see here, I take the first vector, call that u1, this is w1, this is the first vector, and the second vector I just build it such that it will be orthogonal. So in this case, I take the w2, the second vector, w2, minus w2 times u1, divided by u1, u1, I calculate this, and then I get the orthogonal basis. I got this, I scale it a little bit, and I got this orthogonal basis. Now I can calculate the orthogonal projection of V to the W with the orthogonal basis with this formula. After I calculate this, I get a result for the orthogonal projection, which is this vector, and then I take the difference between V to this orthogonal projection. Now I take the norm, and this is the distance between V and the subspace W using the orthogonal projection. This is it. Thank you very much.